Hello, I'm Richard Hollingham. Welcome to the Planet Earth podcast from what must be one of our most unusual locations yet, a World War II bunker on the North Norfolk coast. I'll explain why I'm here in a moment. Also, we'll be hearing about an ambitious project to investigate glaciers in Greenland. And when you go down to the woods today, beware of thugs.
We didn't come up with the name thugger, and we just thought it was quite a interesting way to describe them. You could just call them dominant or over-dominant plants.
I'm at Weybourne beside a solidly built concrete building, a bit like a brick, on a slope above a pebble beach just beneath us. Behind us, there's a tank museum, a gun emplacement, and that beeping noise you can probably hear in the background is one of the scientific instruments of what this place now is, an atmospheric monitoring station. And with me is Brian Bandy from the University of East Anglia. Describe this place for me. What are you doing here?
We're set up to measure chemicals in the atmosphere, basically, and meteorological parameters, 24 hours a day, 7 days a week. We are here because of an ex-professor who very kindly got money in to convert a World War II command bunker into the very high-class facility it is now.
Just explain what this beeping is going on in the background. It's almost like a musical little jingle.
It's an audio instrument which puts 4 different frequencies of sound into the air, and depending on how it comes back in its reflection, we can get information concerning the wind speed and direction and temperature.
So it's raining a little bit at the moment. It's been very stormy today. You can see these bands of cloud kind of coming over the coast. We're looking north here. So where's this all coming from, this weather?
We're ideally situated here to measure air masses that originate in very, very many source regions, as we call it. We routinely measure output from the Arctic Circle. We can measure pollution plumes from the mainland Europe, and also we pick them up from London, the Midlands and places nationally.
Now we've got this block behind us, which is the bunker itself, and then beside it a scaffolding tower. This has got some of the instruments on it. I think most notably there's a clear plastic tube, almost like a drain pipe, coming down and then disappearing into the building. And this is your monitoring tower, really?
That's our main inlet. The majority of the air that we measure comes down that pipe, and then we port it through the wall into the main laboratories, and we've got 2 air-conditioned laboratories.
And why are you doing this? Why are you measuring all this stuff?
Well, I can answer that in 2 different ways, really. We work in a system of long-term measurements, so we're trying to build up a climatology of the measurements, if you like, what the trends are in the measurements. And we also work in what we call intensive campaign mode, which is what we're doing at the moment, with measurements being made by colleagues in the Met Office and the University of Manchester.
Well, out of the back of the bunker, or atmospheric monitoring station, is a sea container. If I go inside, there's a door on the side. This belongs to the University of Manchester, and in here is James Allen and Nikki Young. It's a sea container full of computers and equipment and glass jars and tubes and monitoring bits and pieces. What are you doing in here, Nikki?
Basically, we're looking at the particulates in the atmosphere. So we're in quite a rural area at the moment. So from being here, we can see normal rural background composition levels, and then hopefully see some things from, say, London and other UK cities.
Now, James, you're also from the National Centre for Atmospheric Science. Is there a long-term goal of this sort of work?
One of the things we're interested in is how these soot particles are modified by the atmosphere after they're emitted, because we can make these measurements that we're doing here in the middle of cities where there's lots of the pollution around. But this is where it's very fresh, but we know that the atmosphere kind of modifies the black carbon as it floats downwind. And what happens is that these modifications then affect how much of an impact these black carbon particles have on things like climate and air quality.
So, Nikki, this monitoring work, these particulates in the atmosphere that come from the cities that you're monitoring here, they have implications for climate as well?
That's the big question. Yes, they do. We don't fully understand what these impacts are, so we're investigating different parts of them, so the properties, whether they like water, so whether they like making clouds. Obviously that's more of the weather scale, whereas climate's, the big long-term thing. But our records just don't go far enough back. So that's why we're making measurements now and just seeing if we can feed them into climate models, which is the best thing we've got right now, to see what the future impacts will be.
We're back outside and to the corner of the site, overlooking the gun emplacements and the salt marsh beyond that, is Jeremy Price from the Met Office, you're fiddling with this fridge-size box in the car park here. What is it? What are you looking at?
I am, yes. It's a Doppler LiDAR. It's basically a device which can measure velocity in the atmosphere, and it can also pick up signals off clouds and things. It works on the principle of, Doppler, hence Doppler LiDAR, but gets its...
It's almost like a speed gun for clouds.
Yeah, you could call it that if you like, yeah. It uses aerosol particles, the dust particles in the atmosphere, as a target, and gets a Doppler velocity off those.
So you're looking at the clouds passing directly overhead over this?
That's right. We can point the beam pretty much anywhere we like, but at the moment we've got it pointing vertically, and what that does is it can give us a vertical velocity, and it can also detect the cloud base and where the cloud is. So we can see clouds as they advect over the site and then move away, so we get the evolution.
There's plenty of clouds coming over today, these great bands of rain coming over. It's blue sky at the moment. There's another band of cloud coming towards us. Why? Why do this?
What we're doing, actually, we're doing an experiment which we've called Coalesce, and it's to do with boundary layer clouds, actually. Not so much the big, deep convection we've got today, but it's more shallow convection. And you get layers of stratocumulus cloud forming at the top of the boundary layer. And these clouds can basically ruin your day because they can blot out the sun.
So what do you mean by boundary layer?
By boundary layer, we're talking about the lowest 2 kilometres or about 6,000 feet from the surface upwards. It's an area, we live in that area, so it's an important area that we need to understand. And the big question is are these clouds going to thin, and are they going to break up? Are we going to get some sunshine? Or are they going to stay thick? Is it going to remain cold and clammy all day?
So it's not talking really about rain, it's just how nice your day is going to be from a forecaster's point of view.
That's right. It's to do with sunshine and temperatures, because if it's cloudy, the temperature's going to stay low during the day. However, at night, it's the other way around, in fact. If you've got cloud, it stays warmer. So from a point of view of forecasting things like frost at night, we want to know whether there's going to be cloud there or not. So the presence of stratocumulus is quite important, and getting the forecast for stratocumulus is quite important as well.
So you've got the clouds coming over the coast here. I mean, that's no good because that's just a snapshot. Do you presumably have to take other measurements at some point?
That's correct. What we've got actually is we've got 3 sites over East Anglia. So I'm based at Cardington in Bedfordshire, and the Met Office has a research site there. We've got another site at a place called Denver Sluice, actually, which is out on the flats.
That's the sort of fenland area, isn't it?
It's the fenland area, that's right. And in fact, the flat landscape is good in a way because it doesn't affect the boundary layer too much. So we've got this nice flow of air. It comes off the sea, and we're using Wayborn to measure the initial conditions as cloud comes off the sea. And then we watch the evolution of the cloud as it advects over the land then towards Cardington. And the big question then is, will the cloud break up? Because as it comes off the sea, it comes over the land, and the land tends to warm cloud more than the sea does. So that's basically what we're trying to observe.
And this presumably is all about weather forecasting and getting better forecasts, knowing what's going to happen.
That's right. I mean, the ultimate aim of the observations that we take is it goes into basic atmospheric research and to improve the forecast models and the numerical weather prediction.
Does it surprise you, doing this sort of work, how little we actually understand what's going on? It strikes me as fairly fundamental.
It doesn't surprise me anymore. It did when I came into the field. I used to work in the upper atmosphere, and where there's hardly any observations at all. And when I came down and started studying the boundary layer, I thought, well, what's left to do? But I quickly learned that there's an awful lot left to do. Yeah.
Well, thank you all very much. You can see some pictures and video of the bunker here on our Facebook page. To find it, just search for Planet Earth online. This is the Planet Earth podcast, and at the risk of sounding like Crime Watch, here's a list of thugs to watch out for next time you go for a walk. Nettles, brambles, ivy and bracken. They're known as thug species because of the harm they can do to the diversity of woodlands. And new research, led by Rob Mars from the University of Liverpool, suggests they can be more damaging than species of invasive plants. I joined Rob for a walk through some woodlands on the outskirts of Chester so he could explain more.
Well, the two here are obvious. There's bramble, which is, everyone likes in the autumn because it provides good berries, and nettles, of course, which is a well-known one which stings people. The issue with both of those is that they grow well, they produce a lot of biomass above ground, and therefore they can shade out our less competitive species. One of the other issues is, of course, that we are actually looking at this against a changing baseline of atmospheric nitrogen depositions. Over the last 50 years or so, there has been an increase in nitrogen, and this has actually provided a signal of change in species composition of the vegetation of Great Britain. And we tend to be finding species that respond to fertiliser out-competing other species.
So there are more of these sort of don't want to get too close actually because there are nettles right next to us. More of these thug species like the nettles and the brambles. And actually look through here, if you just crouch down, it's dense with those, nothing much else there.
Yeah. Well, that's true. And what's actually happening in the wider countryside, as opposed to just in woodlands, is we're seeing a process of biotic homogenisation, where, if you like, the many species that we used to have are being reduced, and we tend to be getting more species with the same traits, those that can grow fast, capture nutrients, and outcompete other species. And that's across more or less all habitats. We're seeing this trend.
I'm intrigued about this idea of them being a thug. I mean, they're not actively pushing other species out, are they? They're not sort of, barging them out of the way.
Well, we don't know that. No, I mean, we didn't come up with the name thugger, and we just thought it was quite an interesting way to describe them. You could just call them dominant or over-dominant plants, which I think is probably my preferred wordage.
Okay, for us, walking through this woodland, we can walk down the central path. There are a few smaller paths off. We can't get through this area of the brambles and the nettles. It's just too dense. So it's a pain for us. It doesn't look quite so nice. But what's really the big deal with these sort of plants?
Well, I don't think whether they're in the way for humans or not is relevant. I'm quite happy to wander through here, or at least I get my students to do it, because that's just how woodlands are. These species are there, particularly bramble. They're not particularly nettle. They're not particularly pleasant to work with. But if you do need to walk through them, you just need to walk through them. The issue really is that they have the potential to displace other species, and that's where I guess our worry is. I mean, you could argue that it's perfectly reasonable to just allow this process to happen. It's sort of natural, although we are probably enhancing it with the eutrophication that's coming from the atmosphere.
So more nutrients around.
Nutrients, yeah. But also, here we have a lot of dog walkers. And although they pick up their the faeces, the dogs are still urinating, and will be adding nutrients to the vegetation, and that's enhancing the growth of these particular plants.
Well, actually, we've seen quite a few dog walkers here. Is that why, if you walk along this path, there are the nettles and these other thug species either side of the path, do you think? Do you think that actually has an impact?
Well, that's one explanation. I mean, there's also possibly a bit more light in those areas, but it certainly will, or should at least, enhance their growth, yes.
So if you look at the bigger picture here, this means that our woodlands are becoming less diverse.
Yes. And certainly if these species increase, then you would expect to see a reduction in woodland species diversity. On the other hand, if they reduce in the future, there's a potential for the diversity to increase.
So what do we do about this? I mean, do we do anything? Is this just a natural process or a semi-natural process? Just let woodlands get on with it?
Well, one can do that. The point that worries me is that if we lose too much of the diversity, then we will have a much harder job to re-establish it in the future. And it's also set about where the money should be invested in conservation generally. One of the things we showed was that, in fact, the potential for these species to affect the native plant species was actually much greater than invasive aliens. In some places, invasive alien species, rhododendron, Himalayan balsam, and so on, are very problematic species in British woodlands. They've all been introduced by man. They cost a huge amount of money to control, but in woodlands, nationally, their impact is potentially less than that of native species. Or to put it another way, the native species is potentially greater than the alien species. So I think our research was a bit of a wake-up call just to show that we need to essentially be looking out for it as much as anything.
What does this mean for the future? Does this mean we just have to watch out for these sort of species, that our woodlands don't get consumed by nettles and brambles and bracken and ivy, these sorts of species?
Well, I think we should be on the lookout, and if I was involved in active nature conservation as a research policy maker, I'd be considering potentially putting some research in to find out how to manipulate the communities like this, where there is quite clear dense bramble and nettle, to see if we can actually rejuvenate them and make them more floristically diverse.
Rob Mars from the University of Liverpool. There are pictures of the wood on our Facebook page, and you can read more about Rob's research on Planet Earth Online, where there are also some interesting reader comments. Here's a money-saving tip now. Don't bother buying a map of the centre of Greenland. If you've ever seen one, it looks like a blank piece of paper representing a vast area of nothingness. This enormous ice cap is the second largest body of ice in the world, covering some 1.7 million square kilometres. If it melted completely, then according to Met Office estimates, global sea levels would rise by 7 metres. Glaciologist Tavy Murray from the University of Swansea is one of the leaders of a project to investigate, using a network of sensors, the birth of icebergs from the glaciers around the edge of Greenland. Before she told me what this new research involved, I asked her to explain how the country loses its ice.
Greenland's the biggest island on the planet, and about half the snow is delivered to the oceans through these just a fairly small number of outlet glaciers around the edge that are dumping icebergs into the fjords. And in fact, they're calving really regularly. Calving is when a piece of ice falls off the end of the glacier, it breaks up and it falls into the fjord. And this glacier is calving so much ice that the fjord is obscured. You just see, when you look at it, you just see lumps of ice, and you have to go quite a long way down fjord, tens of kilometres, before you'll actually see open water, and you could actually put a boat in there or anything like that.
It's how this calving process works that Tavy's research group is trying to understand. So they've come up with a plan to place a network of monitoring sensors across a glacier. These unique instruments are being developed at some expense by the University of Newcastle and Thales Research and Technology, and they're not even expecting to get them back.
We're actually planning to lose some of our sensors, possibly by the end of the project, all of our sensors. And what we're going to do is the sensors will measure where they are on the ice, and they will talk to other sensors around so that they will calculate where they are quite precisely. And then that data will be transmitted back via a satellite link to the UK. So just before an iceberg calves, we'll know exactly where that ice is, how fast it's moving, whether it's lifting up. And then as the iceberg calves, we'll lose potentially part of the network, and we'll carry on measuring with the rest of the network, and we won't have lost that data.
And why is this useful? I mean, can this be used in predictions of global climate, sea level rise, those kinds of things?
Calving is a really important process because it controls the mass loss from Greenland. The snow that falls on Greenland, about half of it just melts around the edges and it runs off in kind of rivers off the ice. And about half is coming out through these glaciers that end in fjords, and we call them tidewater glaciers. So these are the glaciers that are key, and they're key because when we've seen increases in mass loss from Greenland, it's all been associated with changes in how these glaciers are flowing. They've speeded up, basically, and carved more icebergs.
Tavy Murray from the University of Swansea, who plans to deploy the sensors for the first time next year. I'm sure that'll be a story we'll be coming back to. And that's the Planet Earth podcast. Any comments very welcome via our Facebook page. I do also want to mention some of the things we've got coming up over the next few weeks, including audio diaries featuring a dead whale and how to turn power station emissions into brick. I'm Richard Hollingham from a rather blustery Weybourne in North Norfolk. Thanks for listening.